Okay, here we have our fourth example. PQ, PR are two chords of a circle with center O. OA perpendicular to PQ. OA perpendicular to PQ. OB perpendicular to PR. So there are two perpendiculars given, so we can apply our theory. So OA and OB are perpendicular drawn from the center, so we can apply the theory. So we'll mark the result. We just mark the result and we need to prove it. Okay, so with the perpendicular, with our theory, converse theory, PQ is bisected by OA. A is the midpoint of PQ. Similarly, B is the midpoint of PR. Okay, so that's why what we marked here. So show that PQ squared, PR squared, OB, OA. Okay, PQ is the length of the chord PQ, and PR is mentioned by the length of the chord. OB is the perpendicular distance, OA another perpendicular distance. So if you check, all the lengths are given with the square. So theoretically, where we get squares, so in our syllabus we have two areas. When we got a binomial square, from the result we'll having power of 2, we'll having squares. Okay, so then if we use Pythagoras theorem, we'll have squares. So these are the two main areas. Theoretically we'll have squares. So we need to use one of the knowledge, one of the theory to find this answer. So as we know, during this chords of circle, we are always dealing with the right angle triangles. So the suitable one is Pythagoras theorem. We'll apply it, Pythagoras theorem. Okay, so if you look at the figure, we don't have a right angle triangle yet. Is there any right angle triangle? We have PQ chord and PR chord and OA and OB. With the previous exercise questions, you have a quadrilateral here. AOBP is a quadrilateral. We don't have a right angle triangle. So how do we get a right angle triangle? So we need a construction here. So the starting, we need to write the construction what we need for the answer. So what is the construction? If you want to make a right angle triangle, simply you have to connect O and P. So with the perpendicular, we can easily pick, we need to connect OP. So join OP. So what is OP? Related to the circle, what is OP? OP is the radius. Another point, so with this equation we'll have two right angle triangles, so we can produce two Pythagoras theorem relation. So if OP is common for both right angle triangles, we'll have we can connect those two relationship into one. So we'll have a single equation like that. Okay, from OP only we can get those two ideas. So first we take we need to mention the theory first, because half of the PQ we need to mention it. So then only we can easily go with the answers. Okay, right. First we proved PA equals to AQ. So you know the theory, perpendicular drawn from the center to a chord bisects the chord. Similarly PB equals BR. So why we are writing initially the theorems? So we need to we need to use this under one of the calculations here. So when we doing calculation, we can't add these steps. So earlier we are writing those answers, so it is easy to go with the answers. So then we'll take the triangle AOP according to Pythagoras theorem, right? OP squared equal OA squared plus PA squared. So that is the first relationship we can have with the mentioned lengths. OA is mentioned, so that's why we think about go with the Pythagoras theorem. Okay, so similarly in triangle BOP, same OP squared is equals to OB squared plus PB squared. So that is our second relationship. Okay, if you check the result of the first relationship and the second relationship, both are with the OP squared. So in your result, in your answers, you have to show, so there are no OP, so we need to cancel the OP, so we can have 1 equals 2 because those are with OP squared. So the next step, we are going to equal these two equations. So 1 equals to 2, which means OA squared plus PA squared equals to OB squared plus PB squared. Okay, so the first step, we check the result what we are going to show, so those are with squares. So then the next step, we check what is PQ, length of the chord, what is PR, length of the chord, OB, length of the perpendicular, OA, length of the perpendicular. So all the lengths are with the squares. So we think, so from where we can get the squares? So Pythagoras is the suitable one. So we put the Pythagoras theorem and we'll have a single equation. Now check the result. What we got? We have OA and OB. We have OB and OA. But OB subtracted by OA. Is that correct? Right. So when we change the side OA into the other side, so we'll get this bracket. Okay. PA, PB are not here in the answer. So instead of PA and PB, we have PQ and PR. So what is PA? Half of the PQ. PA is half of the PQ. Is that correct? PB is half of the PR. So we already shown PA and AQ. So these are equal. So we can apply with this result. The next step, we got another idea. We need to change the name. Just change the name. We have to change PA and PB. The name is going to be changed into PQ and PR. Is that correct? Simple. Okay. So already we showed PA and AQ are equal. So which means it's half of PA. We can directly write it. So OA squared plus, instead of PA, we are going to write PQ half. Half of the PQ. Because A is the midpoint. We shown it. Okay, so instead of PA, we substitute PQ over 2. It's all squared. And OB squared plus, instead of PB, we are going to use PR. So it's half of PR. So PR over 2 all squared. Okay, so now let's check the answer. You have all the names. We have all the names here. So just in this question, we have to change. We have to substitute the names with the lengths. Okay, that is this question, the main part of the question. Now we have to arrange it. in the given order. So first we send the OA, because OB is subtracted from OA. So we send OA and we get the PR here. So PQ squared. So if we remove the bracket, it's PQ squared over 4. Is that correct? So we can take the PR all squared over 2 to the other side. So which means it's minus PR squared over 4. If you remove the brackets, it's PR squared over 4. And then OB is on this side. So we take the OR to the other side. So minus OA squared. Okay, we have the same denominator. So we can write it with the one denominator, not the separated. Okay, 4 PQ squared minus PR squared is equals to OB squared minus OA squared. So let's send the 4, the divided 4 into other part. So we'll have the result here. So PQ squared minus PR squared is equals to 4 into OB squared minus OA squared. So that is what we need to prove. So think how we comes to this question. This is geometry. Step by step you need to check the answer. You need to get a relationship of the answer. How do we go to the shown answer? So first step we check all with the length of the square. So Pythagoras is suitable. Then we make two equation. Then we think we can make these two equation into one equation, because OP is common. So we make it as a one equation. Then we check with the answer. We have two names, two length of the given, but we don't have these two. So what we are going to do, we need to replace it. So we are replacing with the theorem, converse theorem. We are using the converse theorem to replace the name of PA and PB. So we replace it. Then step by step we check the result and we make the arrangements. So after the final arrangement, we have the same result what we have to shown. Okay, this is geometry, simple. So we have to check each and every step what is the result. How can we related the result with our idea? So that is our geometry. Basically this is the idea of geometry. How do we deal with the questions? Okay, so we have another last example, another theoretical example. We'll go for the fifth example.